Okay, in this 5-minute video, we won't have time to cover answers to all the questions, but I've got a graph here that I copied in from Desmos, and we'll actually do a screen share and show you some other stuff in a second. But here I've plotted each of the points in this table, 0, 0, 15, 15, all the way out to 1, 20, 12. And we're asked to estimate the integral of f of x dx with n equals 4. That means what's the area under this function for these values of x and f(x). So in this case, a equals 0. That's the left-hand point of the interval. B is 120. We're out here way to the right. If n equals 4, that means the length of each delta x, or of each rectangle, will be 120 divided by 4, or 30. So that's what these 30s are down here, the length of each rectangle or subinterval. And then if we're going to use right-hand endpoint, that means we want to have the height of the rectangle that we're going to use to estimate the area under the curve as the height, or the y-coordinate, of the right-hand endpoint of each subinterval. So that means the height of this first rectangle is 18. At the right-hand endpoint, the height of the rectangle is 19, and 21, and 12, and so on. So to get the area using right-hand endpoints, it would be, you could find the area of each of these rectangles, 30 times 18, 30 times 19, 30 times 21, 30 times 12. Or you could say 30 times the quantity 18 plus 19 plus 21 plus 12. So we would say A, using right-hand endpoints, I don't know what symbols you use for that, but you could be 30 times 18 plus 19 plus 21 plus 12. Okay, now let's go to Desmos. I'll share my screen. And if I enable this right-hand endpoint, there's the rectangles that I just depicted on the whiteboard. 4 rectangles. If I disable that and click the midpoint estimation, that means I would be using the midpoint of each subinterval to get the height of the rectangle. They all still have the same length, 30, 30, 30, 30, but they have different heights. So you get a different answer for the area of the sum of those 4, or the sum of those 4 rectangles. And then if I disable this, just to give you an idea of what the trapezoidal rule looks like, if I can get this to work here, if I go like this, you can see that if I connect these dots, I've got 1, 2, 3, 4, 5, 6, 7 trapezoids plus this one triangle right here. You probably have a trapezoidal rule in your textbook, a long complicated formula, but the idea is that this first region is a triangle, so we would be using 1/2 the base times the height. And then for the trapezoid, you use the formula for the area of a trapezoid, which, well, you've got the idea. You'll have to look up your trapezoidal rule in your calculus textbook. Okay, so I'm going to stop sharing. I'm going to include the URL to the Desmos graph in the answer to this problem. And by the way, back here on Desmos, I depicted 7 trapezoids. So you'd have a different setup if you only had 4 intervals. You'd have 3 trapezoids in a triangle, because that left-hand endpoint starts at 0, 0. Okay, stop recording.